Well, here in part C, again, there's a little trick to this. Like part A was just flat out, just take it as is. Part B, we had to watch out and we had to factor out because we didn't really have a constant term. Well, here for part C, what we need to watch out for is the fact that, yes, it's in descending order, and I have a constant term, and I have a leading coefficient. The difference is this isn't really general form, because my coefficients aren't all whole numbers. So let's get whole numbers first. What would I have to multiply by to eliminate all those fractions? Well, it looks like if I do everything through by 6, then we should be good to go. So that would be now 6x to the 5th. A third of 6 is 2. And then 6x, and the half of 6 is 3. Okay, and now here's definitely something we can work with. So x is going to equal plus or minus the factors of the last number over the factors of the front number. Don't reduce this. You know, you're like, ooh, this can reduce. No. We want to list all of them out. Otherwise, you're going to eliminate some potential factors. Okay, so x is equal to plus or minus the factors of 3, which is just only thing you can multiply together to get 3 is 1 and 3. What you can multiply to get 6, though, is 1, 2, and 6. So then listing them all out, we have, start with 1, so 1 over 1, 1 over 2, and 1 over 6. So 1, 1/2, and then 1/6. Let me write a little bigger 2 there. Okay, let's go with 3. 3 over 1 is 3, 3/2. And then 3 over 6, which is 1/2, it was already listed before, so we don't have to worry about writing it twice. Okay, so those are all of our potential factors there. 1, 2, 3, 4, 5 positives and 5 negatives, so a total of 10 potential factors. Okay, so now that we've gotten practice just finding the potentials, here in next example, part 6, what we want to do is actually now find the true ones. So what this means is that first of all, we're going to list them out, and then we're actually going to now go into the synthetic divisions and figure out which ones work in the box. Okay, so let's list off. Here's a list of potentials. Okay, so x could be, and looking at that polynomial real quick, every coefficient's a whole number, which is great. There's no powers of x I can factor out first, so let's go ahead and go right into it. So it's going to be plus or minus the factors of the last number of 6, which is 1, 2, 3, and 6. And you know what? As I wrote that out, it made me think, let's go back up into this one. I forgot something, didn't I? That I should have incorporated a 3 also in this denominator. So just so we can clean this up and actually get this correct, let me take these away because I don't want you guys, you're probably sitting there going, Miss Chase, hello. Okay, the only factors of 3 are 1 and 3, but of 6 are 1, 2, 3, and then 6. Okay, so x could be plus or minus 1 over 1, 1/2, 1/3, 1/6. And then when I go 3 over 1, you'll get 3. 3 over 2 is 3/2. 3 over 3 is 1, it's already in there, and 3 over 6 is 1/2. Okay, there we go. So 1, 2, 3, 4, 6 positives, 6 negatives, so there's 12 potential solutions. Okay, I had to have that fixed real quick though. Let's go back to this one though. All right, so the factors of all the back number over the factors of the front number, which is just 1. Okay, so if you go and pair them up, 1 over 1, 2 over 1, 3 over 1, and 6 over 1, really you're looking at plus or minus 1, 2, 3, and 6. So there's all of our potentials that we can work with. So what we're going to do from here is we're going to come in with synthetic division. So let's start with our box. Remember, we're going to go see x cubed. There's the x squared. Here's the x, and here's the constant. Remember to put a 0 in if we ever were missing a term. Okay? All right, now then from here what we want to do is just go to our list and just pick something out that we want to try. Let's say 1. 1's in the list, let's try that. So let's drop down that, multiply it to the box, add it up. Multiply it to the box, add it up. Multiply it to the box and add it up. Now because that doesn't come out to be 0, then I know that 1 doesn't work. So 1 is definitely not a root. Okay, so I'm going to erase this. Let's try another number. How about, we could do -1. I mean, you have all these numbers we're going to try out. Let's do 3. Let's see about that. So drop the 1, multiply it to the box. 3 minus 1 is 2. multiply it to the box. 6 minus 4 is 2. 2 times 3 is 6, and look, it adds up to 0. So that means that if I want to determine all the list out all the potential roots, then what I'm going to do is I'm going to come over here. So x equals 3, that's one of them. So now let's go back and try to find some more. Remember, every time you do synthetic division, you knock that degree down by 1. So this is really saying at this point x squared plus 2x plus 2 equals 0. Well, I don't know about you guys, but instead of trying to do synthetic division again, I'd rather just factor or use the quadratic. Well, this doesn't factor, so let me go into the quadratic. So x is equal to negative b plus or minus the square root of that b squared, so 4 minus 4 times a times c, all over 2a, so 2 times 1. So x is equal to, I needed a lot more room in here, but hope y'all have some backs that you can work on too, but we have negative 2 plus or minus, see 4 minus 8 is the square root of negative 4 all over 2. Okay, so let me come down here just a second. So x is equal to negative 2 plus or minus, the square root of a negative is I, and the square root of 4 is 2, so 2i over 2. So cleaning this up, because I can divide everything by 2, it's negative 1 plus or minus I. So what that's showing us right there is that technically our other two roots are imaginary roots. The first one is negative 1 plus I, and then negative 1 minus I. So if I go back up to my problem, my degree was 3. One of the roots is x equals 3. The other two, to give me a total degree of 3, are imaginary. But now I've determined all the roots, whether they were real or imaginary, for that problem. So let's try this again with part B.